Late July telemetry showed a sharp rise in stealthy, long-dwell detections. Ransomware groups are abandoning high-visibility encryption for faster automation and deeper persistence. Intrusion analysis reveals a massive focus on smaller targets. Small businesses now represent 80.16% of victims. Breaking this down by industry, the manufacturing sector emerges as the primary focus, accounting for 16.70% of total activity. To maintain this volume while avoiding detection, threat actors are discarding custom malware infrastructure. They are operating entirely within the boundaries of native network tools, a tactic known as living off the land. This strategy utilizes a two-step kill chain. First, exploiting perimeter management devices to establish a foothold, then weaponizing legitimate SaaS traffic to mask command and control communications. Modern defense requires identifying when an organization's own administrative tools, the very systems built for management and security, are executing unauthorized commands. The latest data shows that perimeter exploitation is no longer focused on simple gateways, but is now clustered around the management plane. We see active exploitation of vulnerabilities across FortiOS, Checkpoint Smart Console, and Cisco Secure Firewall Management Centers. Targeting these specific nodes grants an attacker direct administrative control over the security tooling itself. They can essentially rewrite the rules of the network from the inside. In this new landscape, the compromised edge device is rarely the final objective, serving as a temporary beachhead. By chaining vulnerabilities, attackers move directly from the edge into internal collaboration infrastructure like Microsoft SharePoint, bypassing standard endpoint security entirely. This rapid movement allows adversaries to embed themselves into internal sites and public-facing blogs before internal security teams can even identify the perimeter breach. Rigorous patching of edge devices serves to block the high-privilege pathways that lead directly to internal collaboration servers and sensitive data repositories. Once access is established, the payloads are becoming increasingly specialized. A prime example is nForge, a Go-based ransomware designed for operational extortion. nForge ignores standard business documents like PDFs or spreadsheets. It is purpose-built to hunt for roughly 180 specific AI infrastructure formats, zeroing in on high-value assets like PyTorch and TensorFlow checkpoints. Operators used a Langflow flaw to trigger a Docker escape, breaking out of the container to reach the foundational server architecture where these models reside. nForge uses AES 256 CTR in partial file mode to handle massive machine learning models, encrypting only specific segments to corrupt gigabytes in seconds. This symmetric key is then wrapped with an RSA 2048 public key, ensuring only the attacker can generate the decryption keys. Notably, nForge includes no code for data exfiltration. The extortion leverage comes entirely from operational destruction, disrupting AI services and destroying the expensive models that represent a firm's most valuable computational assets. This marks a split in ransomware mechanics, moving away from simple data theft toward targeted denial of service against critical intellectual property. To maintain these footholds, threat actors must solve one final problem: how to maintain command and control without triggering network alarms. The holograph implant achieves this by authenticating to Microsoft Graph using compromised Microsoft Entra ID credentials. Holograph abuses the Graph API to use a mailbox calendar as a two-way dead drop, formatting traffic to match legitimate calendar syncs. Operators plant far future events, like May 2050, with embedded instructions. The malware bits these tasks during regular cycles. To send data back out, the implant uploads encrypted attachments to its own calendar events via a standard send command. The channel is protected by hybrid RSA and AES 256 encryption, which keeps the inbound instructions and outbound data cryptographically distinct from one another. It even includes a secondary DNS tunneling channel to periodically refresh its tenant and secret values, ensuring the access remains persistent even if sessions are cleared. By hiding command and control traffic inside standard Microsoft 365 API calls, attackers render their communications virtually invisible to traditional network monitoring. This camouflage also extends to the browser level. The Chaos ransomware group now utilizes a remote access Trojan called MSA-RAT. MSARAT avoids direct network contact by driving Chrome or Edge in headless mode via the Chrome DevTools protocol. The malware establishes a WebRTC data channel, routing signaling through Cloudflare workers and relaying traffic via Twilio turn servers to appear as standard browser activity. To further secure it, MSARAT layers Cha-Cha Poly 1305 encryption over WebRTC, creating a highly resilient tunnel. We see a similar browser-centric approach with OWare which is deployed through a cross-site scripting flaw in Outlook Web Access. OWare lives entirely in the browser. It persists by storing an encrypted copy of itself in local storage and poisoned offline message caches, reloading every time the user opens OWA. It silently grants owner-level permissions across mailbox folders. Because this change happens at the server level, it effectively survives device re-imaging and password resets. The browser has effectively transitioned into a resilient, persistent command and control infrastructure that survives standard remediation efforts. The data from late July reveals a complete macro attack chain, from the exploitation of management devices to targeted AI extortion and invisible WebRTC tunneling. The common thread across these attacks is the weaponization of the target's implicit trust in their own infrastructure. Recognize that your firewalls, cloud environments, and browsers are now being used as cover. Standard edge patching is a mandatory baseline, yet it fails to address the threat of actors who have already migrated to internal SaaS platforms. Organizations must pivot their focus toward enforcing rigorous identity verification and stricter cloud control hygiene. This involves locking down all internet-exposed consoles and implementing strict multi-factor authentication across every management plane. It is equally critical to monitor for anomalous administrative behavior, unexpected changes to internal content, and deviations in SaaS API data flows. When attackers live quietly inside legitimate, encrypted tunnels, organizational survival depends on actively doubting the integrity of every trusted internal connection.